Hello students, today in this video we'll be learning about some important compounds of calcium. The compounds that we are going to learn are calcium oxide, calcium hydroxide, calcium carbonate and calcium sulphate. In addition to that, we'll also see the composition of the mixture cement. So we'll see one by one. First, calcium oxide. We'll decide what will be the common name for it. Calcium oxide is otherwise known as quicklime. Its chemical formula is CaO. Coming to the next compound, calcium hydroxide. Calcium hydroxide is commonly known as slaked lime and it has the formula CaOH twice. Coming to the next compound, calcium carbonate. This is commonly known as limestone or chalk. In some cases, we also refer to as marble. And calcium carbonate has the formula CaCO3. Next is calcium sulphate. Actually, the compound has the name calcium sulphate hemihydrate. Here, the compound is commonly known as plaster of Paris. And it has the formula CaSO4 dot half H2O. So in this video, we'll be learning the different methods of preparing these compounds. First, we shall see the preparation of calcium oxide. Calcium oxide is prepared by heating limestone. What is limestone? It is calcium carbonate. When calcium carbonate is heated at very high temperature, around 1070 to 1270 Kelvin, in a rotary kiln, we find that it will be decomposed to produce calcium oxide and carbon dioxide. This carbon dioxide escapes out. You find that calcium oxide is a white amorphous powder and on exposure to atmosphere, it absorbs moisture and carbon dioxide. So what happens when it absorbs moisture? You find that calcium oxide, when it absorbs moisture, you find that water droplets are absorbed and it forms calcium hydroxide. The calcium oxide, when it absorbs carbon dioxide from the atmosphere, it will change back to calcium carbonate. When calcium oxide is mixed with sodium hydroxide, we get a mixture. This mixture is known as soda lime. And the soda lime is very important in organic chemistry in order to help decarboxylation reaction. You find calcium oxide is basic in nature and so it reacts with acidic substances like silica to form calcium silicate CaSiO3. This is found to be important in the removal of the infusible substances into fusible materials in metallurgy. This reaction occurs at very high temperature. You find that calcium oxide also reacts with the acidic phosphorus pentoxide with the formula P4O10 because phosphorus pentoxide exists in the form of a dimer and it forms the compound calcium phosphate. Calcium is having valency 2 and phosphate is having valency 3. On crisscrossing the valencies, we get the formula Ca3PO4 twice. The compound is known as calcium phosphate. You find calcium oxide is an important material for preparation of cement. It is also used for the manufacture of sodium carbonate from caustic soda. Now we shall see the preparation of calcium hydroxide. We begin the preparation of calcium hydroxide from quicklime. What is quicklime? It is calcium oxide. When calcium oxide is treated with water, you find that when little amount of water is added to quicklime, it results in calcium hydroxide and the reaction is found to be exothermic in nature. You find that this reaction is known as slaking of lime. What is lime? Lime is quicklime, that is calcium oxide. So calcium oxide on reaction with water, it forms calcium hydroxide, which is otherwise known as slaked lime. The lumps of calcium oxide breaks down into amorphous powder. This amorphous powder is sparingly soluble in water. What do you understand by amorphous powder? It is a compound which does not have a regular geometry. You find that two types of solutions are formed when we are adding quicklime to water. The aqueous solution of quicklime in water, it is known as lime water. That means it is a dilute solution of calcium hydroxide. The suspension of slaked lime in water is known as milk of lime. Lime water is very important in the qualitative analysis of carbonate ions. You know that calcium hydroxide, when it is treated with carbon dioxide, that is produced when carbonate salt reacts with acid, you find that it forms calcium carbonate, which is insoluble precipitate, which is white in color, and it also results in water. With the result, what you observe is that when carbon dioxide is bubbled through lime water, it forms a milky precipitate. It turns milky due to the formation of calcium carbonate. Now, when we are passing excess of carbon dioxide through this solution, what happens? On passing excess of carbon dioxide through lime water, the milkiness disappears. What is the chemistry behind that? You find that the compound formed is calcium carbonate and water. This calcium carbonate and water, when it further reacts with more amount of carbon dioxide, it forms calcium hydrogen carbonate, which is completely soluble. You find that calcium has valency 2, bicarbonate has valency 1. With the result, the formula is CaHCO3 twice. This is calcium bicarbonate. Calcium bicarbonate is completely soluble in water. With the result, the milkiness of the solution disappears. That is, when we are passing excess of carbon dioxide through lime water, the lime water turns clear due to the formation of calcium bicarbonate. Another important reaction of this calcium hydroxide is that It is used for the preparation of bleaching powder. Calcium hydroxide, when it is treated with chlorine gas, it forms a mixture, that is calcium chloride. It also forms calcium hypochlorite along with water. So, mixture named bleaching powder is formed with the composition CaCl2, CaOCl2 dot CaOH twice dot 2H2O. So this is the composition of bleaching powder. The main ingredient being calcium hypochlorite with the formula CaOCl twice. So the compound is named as calcium hypochlorite. It is important germicidal used in the purification of water. Thus, we find that calcium hydroxide is important in the preparation of mortar. It is also important for making whitewash. It is used in glass making, in the tanning industry, that is in tanning of leather. Then it is used for manufacturing bleaching powder, etc. Calcium carbonate normally occurs in nature in different forms like limestone, chalk, marble, etc. You find that it can also be prepared by passing carbon dioxide through slaked lime, that is calcium hydroxide. So when calcium hydroxide reacts with carbon dioxide, it forms calcium carbonate along with water. You find that it can also be prepared by treating calcium compounds like calcium chloride with sodium carbonate. So what you get? You find that it forms calcium carbonate along with sodium chloride. This calcium carbonate is a white fluffy powder which is insoluble in water. When it is heated at very high temperature, you find that it will decompose to form calcium oxide, that is calcium carbonate. On thermal decomposition at around 1200 Kelvin, it undergoes decomposition to form calcium oxide and carbon dioxide. Now, what are the reactions of calcium carbonate? You find that calcium carbonate react with hydrochloric acid. So what will be the product form? You find that it will react and produce calcium chloride. So for which we require 2 molecules of hydrogen chloride. So then you get calcium chloride along with H2CO3. H2CO3 is carbonic acid which decomposes to form water and carbon dioxide. Instead of using hydrogen chloride or hydrochloric acid, we can use sulfuric acid also. So what will be the reaction here? Calcium carbonate, when it reacts with sulfuric acid H2SO4, the products formed will be calcium sulphate and H2CO3. H2CO3 is an unstable, weak acid. So it decomposes to produce H2O and carbon dioxide. Calcium carbonate is used for preparing quicklime. It is also used in the manufacture of high quality paper. It can be used as antacid. It is a constituent of chewing gum and in cosmetics. The next compound that we are going to learn is calcium sulfate. Calcium sulfate is actually a hemihydrate that exists and it is prepared from gypsum. Gypsum has the formula CaSO4 2H2O. This gypsum, when it is heated to around 393 Kelvin, it decomposes to produce CaSO4 half H2O plus 3 by 2 H2O. Is it clear? So you find that calcium sulfate dihydrate, that is gypsum, on heating decomposes, it undergoes dehydration to form CaSO4 half H2O plus 3 by 2 H2O. So you find that we never get the compound with 3 by 2 H2O. So you find that to balance the equation, we have to take twice of the quantity. So that is 2 CaSO4 2H2O. On decomposition, it forms CaSO4 twice H2O plus 3H2O. Hope it is clear. So here on multiplying the above equation with 2, you have 2 times of CaSO4 twice H2O giving CaSO4 2 times into 2 into half, that becomes 1 H2O, and plus 3 by 2 into 2 times of water, so that becomes 3 H2O. Instead of heating the compound at 393 Kelvin, if the temperature is above 393 Kelvin, you find the product formed is anhydrous calcium sulfate. This anhydrous salt or the dry salt that is formed is known as dead, burned plaster. So, dead burnt plaster is the anhydrous product formed by heating gypsum at a temperature above 393 Kelvin. The compound formed on heating gypsum at 393 Kelvin is otherwise known as plaster of Paris, as it resembles the rocks of Paris. And another important property of this plaster of Paris, otherwise known as POP, is that this calcium sulfate hemihydrate, on adding water, it reacts together, it undergoes hydration and it forms CaSO4 2H2O. That means 3 by 2 molecules of water are required. So you find that the reverse reaction of formation of plaster of Paris occurs when we are adding water to the compound, and this property of plaster of Paris is used for making statues. It is used for immobilizing the affected part during bone fracture. sprain, etc. It is also used in dentistry. The important building material called cement was first introduced by an engineer named Joseph Aspdin in the year 1824. It was prepared out of three main constituents, that is limestone, clay and gypsum. The composition of Portland cement is CaO is around 50 to 60%, that is calcium oxide, that is formed by the heating of limestone, is the maximum with 50 to 60%, followed by silica, which is 20 to 25%, alumina Al2O3 is around 5 to 10%, magnesium oxide is around 2 to 3%, iron oxide Fe2O3 is of the composition 1 to 2%, and some amount of sulfur trioxide is present, which is around 1 to 2%. You find that the important property of cement is that this limestone, clay and gypsum is heated strongly in a kiln and we get a fused material which is known as cement clinker. This cement clinker is powdered and it is mixed with 2 to 3% of gypsum. The purpose why we are adding gypsum is because it has to delay the setting of cement. Otherwise, cement crumbles down faster. To make the cement stronger and durable, we are adding some amount of gypsum to slow down the process of setting of cement. Cement, when mixed with certain amount of gravel and sand along with water, results in a hardened mass which is known as concrete. When it is reinforced with iron mesh, you find that it forms reinforced concrete. So, the purpose of adding gypsum to cement is to make it more strong and durable.